Hey everybody, and welcome back to the Foundations of Algebra. In today's lesson, we're going to talk about multiplication of algebraic expressions. We understand that algebra is the study of the operations on the real numbers, and we've made quite a bit of progress studying those operations. We know that there are only two, addition and multiplication, and in our last couple of lessons, we really knocked off addition. So let's get to work on multiplication. Just like addition has its main principle, and remember, the only things you can ever add are the same things. And when you add same things, you get the same things. So that was a pretty exclusive principle. The things have to be exactly the same before you even think about adding them. In contrast, the main principle of multiplication is you can multiply anything by anything. You can do it, okay? It doesn't matter what the things are. Anything by anything. So, for example, with multiplication, which, by the way, always just works straight across. That's how you multiply, straight across. That's never going to change. When we're dealing with fractions like this, we just go straight across, right? So 2/3 times 4/5. First of all, I have to point this out. Thirds and fifths are different things, but yet here we go multiplying them, right? We couldn't think about adding them, but multiplication, no problem. And how do we do it? Straight across. 2 times 4 is 8. 3 times 5 is 15. 8 15ths. Multiplication is going to be a ton easier than addition. So let's put it to work. All right, so let's say you want to multiply 2xy squared times w cubed z. First of all, can we multiply those things together? Xy squareds and w cubed z's? Of course we can. You can multiply anything by anything. We couldn't think about adding them, but multiplication, no problem. And how do we do it? Straight across. Just mush them together. You ready? There it is. Game over. That's the answer. 2xy squared times w cubed z just equals 2xy squared w cubed z. Game over. See how easy that is? Multiplication is way easier than addition. See how nice this is? How about 3c times 4ad squared? First of all, can you multiply c's and ad squareds? Of course. Anything by anything. How do you do it? Straight across? Game over. There it is. 3c 4ad squared. Done. Just mush them together. Put them together. All right? Now, I do have to point something out. We might be able to write this a little bit simpler than we have it here. And you know mathematicians, we're always going to want to try to write it as simple as possible. There's no use writing a big thing if you can write it as a smaller, simpler thing. So what we can do here is we can take advantage of the commutative property. You remember that? Remember that property? That's the property when you're dealing with multiplication. That means you can multiply in any order and you'll still get the same result. So 5 times 4 is going to give you the same thing as 4 times 5. The order doesn't matter in terms of the product, the result. So let's do that here. Why don't we commute the factors around? Let's get the two numbers together, the 3 and the 4. Put those by each other. So that's going to be 3 times 4. And then I'm just going to put the variable parts, the letters, in alphabetical order. That's kind of a standard procedure. So just see how I just move the things around. They're still the same factors, okay? But now I've got the 3 and the 4 right next to each other. Let's multiply those together and get 12. So we have 12ac(d) squared. All right, that's a little bit simpler than the top. It's exactly the same, but a little bit simpler looking, okay? We'll try to do that going forward. All right, here's another example. How about, I'll tell you what. The computer just reminded me. Speaking of keeping things simple, something that's really important that's going to help us keep things simple is the idea of exponents. So just to recall, make sure everyone's on the same page. X to the n, okay, means x times x times x, blah, 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 times x, n times. All right? So that little exponent just tells you how many times the variable x is multiplied by itself. So, for example, x to the third power, or x cubed, is just x times x times x, 3 of them. All right? You guys know that. So let's see how they interact in multiplication. Well, if you have x squared times x cubed, well, just think about what x squared and x cubed mean. Let's write them out. X squared times x cubed is x times x, that's x squared, 2 x's, times x times x times x, that's x cubed, 3. So 2 from the first factor, 3 from the second factor. So it looks like we got a total of 5 x's, right? It looks like we could just write this as x to the 5th. That's simpler than x squared times x cubed. We can just put them together and get x to the 5th. Okay? Guys, you might have learned some shortcuts or heard about them, about how to work with exponents like this. That's not the game we're into, okay? Let's understand what's happening now. We'll just write those out and see how it works out in the end, okay? So x to the 5th. Here's another one. How about x to the 4th times x to the 10th? We're multiplying those together. Well, maybe there's a simpler way to write them. Well, you and I both know that x to the 4th means x times x times x times x, right? 4 of them. And then the other factor is 10 factors of x, right? So let's write all those guys out. And if you count them all up, we had 4 and then we had 10 more. So altogether, it looks like we have 14 factors of x. So we'll write it as x to the 14th. Looking good? Awesome. All right. How about this? X cubed to the 5th power. So we're taking something and we're raising it to the 5th power. Well, if you want to raise something to the 5th power, that means multiply it by itself 5 times, right? So there it is. X cubed times x cubed 5 times. And now, guys, we understand x cubed is just 3 x's multiplied together. By the way, I'm going to drop the little dots. We talked about how multiplication can often be just putting them next to each other. So x, that's really x times x times x. All right? So there's the first factor, another one, 4th, and 5. There's 5 groups of 3 x's, x, like that. So if we put them all together, if my counting is correct, I think we've got 15 total. Does that seem reasonable to you guys? All right. So easy just to write those things out. All right. If you're working with these things, write them out. All right. How about this example? Why don't you guys take a moment? You can pause the video and simplify this. See if you can write this in a simpler way. And I'll meet you back in just a minute. Okay. Well, something squared, you know that just means that thing times itself 2 times. Each of those y to the 4th means 4 factors of y. Put them all down and you can see you've got 8. Hopefully you got y to the 8th. Looking good? Nice. These exponents really help us keep things simple. Beautiful job. All right, so let's put these all together now. Let's multiply and simplify. So in the first couple examples, we're just putting them together. Now, when we try to write them a little bit simpler, we're going to call that simplifying it completely, as we've done in the past. Okay? So how about this? We've got 2x squared y cubed times 5x y to the 4th. First of all, can we multiply x squared y cubes and x y to the 4th? Yes. Automatically, right? Automatically. Because you can multiply anything by anything. How do you do it? Just put them together, straight across. There it is. Why don't we take advantage of our commutative property? We'll put the numbers together, the x's together, and the y's together. Okay? So just rearrange them like that. Now, if you notice, so 2 times 5 is 10. That's no big deal. Why don't we write out those x's and the y's with the exponents just to see what we're looking at? It's going to be 10. So there's 2 x's, the third x. Then we have 3 y's and then 4 more y's. So if we count those up, I think we're getting 10 x to the 3rd, right? We have 3 x's. You can see them here, right here, just to make sure everyone's looking in the right spot. And then 1, 2, 3, 4, 5, 6, 7 y's. So that'll be y to the 7th. 10x cubed y to the 7th. Final answer. Looking okay? Excellent. How about this? How about negative 11 ab squared times 6a to the 4th b cubed? Can we? Yes. Yes, we can multiply them, right? Anything by anything. How do you do it? Straight across. Just mush them together. Here we go. Boom. There's the multiplication. So easy. Let's do our commutative work here. Let's get the numbers together, the a's and the b's. Okay? So just putting them like that. So same thing, just like before. Let's do it. Negative 66, right? Negative 11 times 6 is negative 66. And we'll write out all those a's and all those b's. There we go. So I think by my count, we're going to have negative 66. I count 5 a's. Is that what you guys are getting? Yeah. A to the 5th. And how many b's? 1, 2, 3, 4. 5 b's. B to the 5th. Very nice. Final answer. Negative 66. A to the 5th times b to the 5th. Looking good? Let's try this one. Ooh, now this one. It looks a little bit more involved, huh? Okay, so we've got 2x to the 4th y squared, all that quantity squared, times 5x cubed y. All right, well, we know that we need to take care of anything in the parentheses first, but there's really nothing to do in either parenthesis, right? So let's go out to the exponents, that outermost exponent. What I'm going to do, I'm going to take that 2x to the 4th y squared quantity squared, and I'm going to do it off to the side because there's quite a bit happening in this problem, isn't there? So 2x to the 4th y squared squared. Well, we know what that means. That's just 2x to the 4th y squared times 2x to the 4th y squared. So we can clearly multiply those, just mush them together. Straight across like this. And then we'll use our commutative property to get things by each other that we want to be by each other. X's and the Y's. So 2 times 2 is 4. And now I'll tell you what. Why don't we just in our minds write them out? Okay? So by the way, if you're not feeling comfortable writing them out in your mind, then write them out on paper. There's nothing wrong with it, okay? Until you get comfortable enough to do it in your head, keep writing them down. There's nothing wrong with it. But x to the 4th, I'm going to imagine that's 4 x's. X times x times x times x times another x to the 4th. That's 4 more x's. So factors of x. So a total of 8, right? Are you seeing those 8? If not, write them down. That's okay. I'm seeing 8 factors of x. And then y squared times y squared, that's y times y. 4 total factors of y. There we go. All right. So let me just box this in as some sort of scrap work off to the side, because what I want to do is I want to take 4x to the 8th y to the 4th and bring it up to our original problem. So now we know that the original multiplication is equal to this. There's our 4x to the 8th y to the 4th, right? Now we're back to normal. Let's multiply those two things together. Just mush them together. Let's commute again. So get our numbers together, x's and y's, just like we did a second ago. So 4 times 5 is 20. And let's do this. Let's go ahead and write them out in our brains. So we got 20. 4 times 5, that's no big deal. Now x to the 8th. So we got 8 of them times x to the 3rd, so 3 more. So how many is that total? Can you see them in your brain? 11. Good. That would be x to the 11th. Nice work. Again, if it's hard to write them down in your head, then write them down on paper. So y to the 4th times y. So y to the 4th is y times another y. I'm seeing 5 y's in my head written down. Good. There we go. Guys, the final answer is 20x to the 11th, y to the 5th. Nice work. How about this guy? Cool, fraction, an algebraic fraction. No big deal to us, right? Of course we can multiply them because you can multiply anything by anything, and we're going straight across. So let's do it. x squared times 5x to the fourth, boom. Y to the fourth times y squared z, boom. Right straight across. And now we can use our commutative property and write this in a simpler way. So let's see. What if we wrote it like this? And again, so got the numbers out in front and put the variables in alphabetical order. That's not a rule, by the way. It's just what most people do. So let's see. In the top, we might be able to write them out in our heads. All right. And same thing with the bottom. So how about this? That's going to be 5. X squared, so 2 factors of x, and then 4 more. So 2 of them, 4 of them. That's a total of 6 factors of x. And in the bottom, we have 4y, that's 1y, times y squared, 2 more. So y, 3 factors of y. And then that z is all by himself, that factor. Okay, so the final answer is 5x to the 6th over 4y cubed z. Man, isn't this feeling good? Multiplication is so much easier than addition. I love it. Here, last one. Even things like with roots here, these in this case they're both square roots. If they're the same roots, boom, this is just automatic, straight across. So square root of 5xy times square root of 3wz is square root of 5xy 3wz. Just boom, straight across. The stuff inside, you just mush that together under one root. And now we can reorganize if we want, get the numbers together and put them in alphabetical order, w, x, y, and z. I don't see anything we have to do with the variable parts. We just need to put the 15 in front, w, x, y, z. W, X, Y, Z. All right, guys, excellent job. I hope you're feeling really empowered by this multiplication. It's so much nicer than addition. We really put the work into addition, but now we're flying. Okay, excellent job today. I'll catch you back in our next lesson.